grandeur by now.
Okay, there is Nilesh coming.
Okay, so the important people are here.
Okay. Rick is still missing.
Hey guys, how are you doing?
And Shiva.
Hi, Shiva.
And Shiva is here as well. Can you hear me okay?
Hello.
Can you hear me?
Hello. Yes, we can hear you.
Yes,
Okay, good.
I can.
And okay, I came back. I was away, far away from here. Not that far, but far, just only one far, I should say, to Alaska, and I came back. So we should, I'll share some pictures later on. I think we should proceed with what we were discussing the last time. I see a chat message from Raj that is about probably me getting late, and I'm sorry. I was a minute delay in starting because another chat was happening, and I forgot to start this chat. But now that we have folks already here.
Hi, Nilesh. Just to give a small recap of the day at work for me. So
Okay.
we've been having the Azure Pass demonstrations. We had the first day yesterday, and today was the second day.
Nice.
Today was a little more confusing day. I got totally confused with the Azure Service Fabric and certain things. Probably we'll talk it off before the class wraps up. So probably we can do it one-on-one or something like that. So
Yes, we should.
a lot of things just totally confused me now. So.
Yeah, it can, especially when it comes to unique words that people describe. They may be specific to a particular company, and
Right.
that might cause some confusion among people. There is, by the way, there is a deliberate benefit to confusing people from the point of view of people who sell services.
True.
They want to create uniqueness, right? Let me share my screen. So
Right.
the sharing my screen right now.
Yeah, I mean, there are questions like, Nilesh, what is the Azure ARM template? Why is it different? Why do we need it? Why is it different than the open source tools like Chef? And, why do we need all this stuff? So.
Right. So I am just making sure that I share my screen, which I did.
Okay.
And so when lots of people are selling stuff to a customer, the idea is that they want to remain unique, right? So this uniqueness is what people strive to obtain, right? People strive to obtain uniqueness, and if they are not unique, then it's commodity. And when it is commoditization, then what happens to commodity products? When a product is commodity, the price is the only factor in negotiation. And when price becomes the only factor in negotiation, then the customer wins. And the problem is that you want these, sellers. The sellers want to win business. They want to become more profitable than other people. And you can do that. You can charge more money by remaining unique. And if you don't do that, you become a commodity. And when you become a commodity, the customer wins. If you're not a commodity, then you are unique in some sense. And in that case, your uniqueness is the way to distinguish. And when you are able to distinguish and differentiate from other people, other services, other things that people sell, then you get to command a premium price, a premium salary, a premium position, a premium something you want. And you can also do the same thing by basically creating, as an individual, you have to create uniqueness among you that differentiates and distinguishes you from other people. And so when you are creating, say, a profile of yourself, creating excuse me, creating a resume, talking to somebody about something, you want to talk about your uniqueness, so that you then command a premium power, premium salary, premium position. And if you don't do that, then you are boiling down to the minimum wage. Minimum wages will apply, and that is like $9 or $10 or whatever, that depend on the state. That's what you will eventually end up, $9 per hour, if you do not have a way to differentiate. Now, why did I say all these things? When you're talking about something like Azure Service Bus, the idea is,
yes, that seemed to be unique. Sorry to interrupt you. Yeah,
I know. So they deliberately create some component in their service which is unique and different from any other cloud service provider, so that they can then talk about features and differentiation and money, as opposed to just the bare amount of money. And that is what is the root behind this element. It's nothing that different, but they just describe it to be so different that it tends to confuse people. So we'll talk about that, not right now. But remember, differentiation as an individual is very important. Differentiation. You should differentiate yourself, so that other people that compete with you for a given position, and there are this person number one, person number two, like that, lots of people competing for that same position. If they do not differentiate, then this employer will likely give them minimum wage. You don't want that. So you have to differentiate. That is exactly what everybody will try to attempt to do, is to tell everybody else that they are different, they are unique, they are better in some sense than others. And that's the game that everybody plays. And so you see Azure is no different, and that's what's going on. Okay, I think that's a good point. So you should make a list of all things that you think is confusing you, and let us talk about that one-on-one. Okay, so you should do that maybe after this session or some other time, not right now. And let's continue our discussion with a brief recap of what we did the other day. I remember you had, by the way, a brilliant question that you asked that led to this new exercise the other day. If you remember, you out of the blue asked me this question, which is this question. And the question goes like this. I think you asked, show me some example templates about Azure's, no, not Azure's, what's this company called? Amazon. Does Amazon have other templates to use in case of what we would like to? So I opened up a search that led us to here. And in this search, we found out that there are lots of service templates to ready-made consume. And so we just ended up starting this auto-scaling template by launching the stack. And then we, out of the blue, did an exercise. The exercise which we did, it was completely out of the blue. I did not even plan for it. And then, in fact, if you recall, I I did something like this, that I basically started that auto-scaling stack using CloudFormation template. That template is available in this link. And then we constructed that auto-scaling stack using this template, for example, which I have reproduced it in form of a copy in line number 3, which is I'm pasting here for you. So that's the JSON file that I used, this JSON file, which I imported into into CloudFormation, which goes pretty much like here. So you go to CloudFormation stacks and then create a stack, and here you provide upload a template, and you can just upload a template that you might have. And that JSON file, which is available here in GitHub, this raw file that you have in the last link in your Slack chat, that link basically creates a new stack. That stack looks like this, where we were able to extend the stack out, expand it, and then shrink it on our own by doing something specific. That thing that we did that grew the stack was stress for a period of 300 seconds, and do this same thing twice. And when we did this stress out the CPU 2 times for a consecutive period of 5 minutes, twice, then this box was considered to be overloaded. And so a new box got created. And then after this duration finished, that we saw that the box cooled down again. And at that time, we found that this stress goes away, and it cooled down for a period of 300 seconds with no stress twice, like for a period of roughly about 10 minutes. Then we decided that, the boxes are not stressed enough, so we should kill this guy and shrink again. You saw that live example, and I that was the first time I ran that specific thing the other day based on a request from you that you wanted us to play. So we just on the fly did that thing, and we increased our stress levels pretty much like this, and then reduced the stress again by not doing anything. And so the first segment here was the way to, sorry, I should edit that one more time to make it clear. And that command is like this. So those 2 commands we were able to run. First one was installing htop and stress, and then the second one was to run stress again. And when we did that, we were able to see auto scaling example live running based on the logic that we have, the desired state, the actual state, add 1, and then no load, reduce 1, like that, based on the alarms that were kicking in. And that the exercise we did, which I think was nice that you prompted it to happen. So thank you, Shiv. Now, what we were doing the other day also, we began with an example of Terraform exercise. Terraform exercise is available in that location here. In our virtual machine, we saw that we did run Terraform. We started the stack. Then we did a bunch of things with it, including some CloudFormation work, and then we destroyed the whole thing at the end of that session. Now, this machine still has that same Terraform stack loaded up right there. So you can see it. Excuse me. This cough has not gone fully yet. It's still coughing a little bit. And so what I was going to continue discussing is this illustration of the Terraform exercise, which we have in form of source code available to us in that folder here, which I think you should have already in this link, which I'm also going to paste for you. And that link is available here. And so that this link gives you access to that Terraform exercise. So I'm going to click on that link again. That link takes us to this location where you will find that that exercise is defined. And here we go to this. By the way, are we recording? Are we recording? Yes, we are. Okay, just checking that. So if you go back to that link here, it will take you to this GitHub location. And that GitHub location is what we have here. It opens up like this, and we are able to clone it. And so what I will like to do is make sure that you are able to clone by just copying that download clone link, clone that link here, get this clone link, go back to your workstation, and then do something as described in this exercise in this location, where you basically clone the entire repository locally. And then we will like to go and read what is inside that folder that gets downloaded and understand it, and make sure this time run it in a step-by-step fashion so that we are able to clearly understand what is Terraform doing and how can we make use of Terraform as a tool for ourselves to do something useful, to do something meaningful. So what I'm going to do now is put Amazon on one half of the computer screen and my workstation on the other half. And that is what I'm trying to build. So this is the Amazon screen, and the other one is your workstation screen, which I am going to put in the right half. And in this computer screen, I have my terminal open. I would like to open the Terraform folder and go inside the Git repository and then open Atom editor in there. So you will see that Atom opens up and shows you the source code behind what we have received from that Git repository. We have taken this entire Git repository and renamed it to be just TF. So that this is a short name that I have renamed. It could be this long name, NTR architecture, AWS, Docker, Terraform. That's what will show up if you do not rename this name TF. That's what you will see if you just git clone. But what I have done is renamed it to a shorter name TF so that the command prompt doesn't go too long like that. And then I enter inside this folder Terraform, and that is where I open Atom editor. You need to work inside this folder. That's the working folder we have. And that is where we are working right now. And that's where Atom is also open. Now, in order for that project, this exercise to actually begin and functional, you need to establish a connection between your terminal and provide this terminal your credentials to Amazon. And these steps, by the way, I just skipped over and I straight ran the program. But as you know already, we have to have a method of systematically connecting this setup with our cloud provider. So in our example, we are going to use the Amazon's cloud, which requires generating credentials that you can do somewhere here. And you probably know this already by now. I'm doing many times, but you go to your name and get to the security credentials section. And that is where you will find there is a place to generate security credentials. And you can just create one like that. And you create a new credentials pair, key pair, access key, and secret key. And you provide that to this file here, terraforms.tfvars. That file, to begin with, contains an entry that says, change this. That looks like this. So you will say, that Terraform folder here contains a file called terraforms.tfvar that contains these entries. Access key, change this. Secret key, change this. And those values you need to change. You need to change them to the value of your credential that you will receive from Amazon. So specifically, you will receive something like these credentials, access key and key pair. And okay, I think we have more people coming in. Let me see who's here yet. We have, okay, let me get to all of you to understand who's here. Unmute. And where's the list of people? There we go. Okay. Hi, Tyler, Shiv, Raj, Josh, David, Dan, Charles. Hey guys, thanks for joining. So we are doing the Terraform exercise, this time doing one step at a time, incrementally building the exercise so that you can understand how can we use Terraform to construct arbitrary architectures in a variety of clouds. The last time we did this exercise, we just ran it like, one command and it built the whole thing for us in like 2 minutes. But we wanted to discuss something different, which is comparison between Terraform and CloudFormation. So we did CloudFormation study the other day. Today, what I want to do is go back to this exercise and then understand it step by step, understand how to build it, how to modify it, what it means, and how does it play out in the context of this architecture that we want to deploy on N tier. So it's multiple tiers in the Amazon cloud, which uses Docker containers and all of that. We are using the tool called Terraform, which is this tool, terraform.io. It is available in open source. There are lots of documentation for a variety of cloud providers, and all these providers are available. You can see the source code of this in GitHub in this location. That's the tool that we are using. The tool that we have installed here in this workstation is a little bit old. So if you run Terraform here, -v, check the version, it tells you that, it is 0.82, whereas the latest one available is 0.88. So the last time I ran this exercise, it was 0.86. So they keep pumping out new versions like crazy, which is telling you that it is a very highly, popular tool. Lots of people contributing, and you will soon find that 0.90 version is also going to be available pretty much. This 0.88 probably came down like today or yesterday or 5 days ago, apparently. So it's a fresh build. 0.82, this tag 0.82 that I have installed is probably from February. It was December 2016, so that's where 0.82 came out. You can modify and update it to the latest version of the Terraform tool available at that time by running the steps provided somewhere here. So in somewhere along the way, you will find that you can update Terraform if you like. And so these are the steps to update Terraform given here, but we don't have to update, but you can update if you like. I'm not deciding to update it right now, but you can totally change to the version you like by switching over to the latest one if you want to. I think my recommendation would be just stick to what we currently have, play with it, get a feel of it, and then at some point change the version to the latest one and play again, understand it, make use of it. That's how I would recommend doing. Having said, I want to make sure that you are clear with the idea that you have to provide your cloud connection credentials, and that credential has to be provided by obtaining from somewhere like this location, get the security credentials, get access key and secret key. And that's the first step that you have to provide, that you modify back in here. This file specifically, access key and secret key, says change this. You have to go make changes to make it look like this. So you have your keys there in place. And that is this file location here, terraform.tfvars. This specific file has to have your credentials. After having given the credentials to this particular file, you will also notice one thing, which is that that particular file is included in your gitignore collection. So if you go back one step here in the command line and then open Atom Editor, you will find it contains a gitignore file that is actually actively ignoring any file that names tfvar at the end. Extension tfvars is ignored, meaning if you have this file here, this file, it will not, sorry, not this file, the tfvars file contains your Terraform variables. That file is actively ignored by Git. So that's why you see that this particular file which stores your credentials will not be included in your Git commits because of this existence of line number 2 in gitignore inside your Git repository. So you don't have to worry too much about it, but remember, if you are using Git and if you decide to commit and push back to GitHub and you're not using private repositories, which I suspect you are not, your keys like these guys will go and get exposed to the world outside. And you don't want that to happen for obvious reasons. So you do not want to send your credentials out to the internet. That's a caution that you want to make sure that you provide. You do not want to send your keys to the public. So having said that clear, I'm closing this window. Basically, remember that this file is secret, that you have to keep it secret. Don't give it to anybody. And now let us begin running this exercise by understanding line by line, item by item. And our end game would look something like this illustration. That's what we'll attempt to build. So I'm going to erase this content right now, which has lots of markings. And so I will begin erasing this and then talk about what we are building and show you that it actually builds the way we would like it to be built. And so the idea behind this tool is to basically simplify creation of whatever we would like to have in form of a design, a blueprint, in the context of in the context of any supported cloud that we have in mind, and we like to construct these things. So that's what this exercise will do. Back here, the next step of instructions that we have in using Terraform is to see if we can update. If you want to, this is how you update. You don't necessarily do that right away, but you can. Then we have a working folder that we define, which is this Terraform folder. That's where we will work on. So this location that we have, it needs to change to the Terraform location like this, and we will work in this location, this location. Now, having done that part, this next step is for gathering your credentials, which we have done already. And now we will inspect. This write-up that you have is does not walk you through at all in terms of what these file elements contain, but I will do that right now with you. The write-up doesn't do that. So what I'll intend to do is open up that file structure that we have, begin with this file at the bottom. This file contains a bunch of variables that we have defined for ourselves. And let us go see what those variables are. It begins with the first variable called access key. And that has a description called access key, pretty much. So it's a very simple variable definition. It says variable access key. Another variable is secret key. Another variable that we have defined as a value provided is the region. The region that we have chosen in this exercise happens to be US West 1. That's my choice, and I took it. So that's what I have called out as the default value of the region chosen by me. So I can choose to another region by just switching the region to, say, number 2. If I want to go to Oregon, I can just change it like that. But I don't intend to, so I'm not changing. Having said, this value of default can be overridden by a reference in this file. You can provide a value that overrides this value, default, US West 1, by simply calling out another variable value expression in this file. And we have done that already. We have called out the variable access key, and its default value is actually provided to us in the other file here, tfvars. This file has an access key value, which is actually used inside this variable reference access key and the secret key. Those two values are called out in a separate file, which is not in Git. It is supposed to be outside of Git because it contains our secrets. Next one is the value that we have called VPC CIDR block. This is the same idea that we begin when we create a VPC, something like here. You go to the VPC section, and there you will find that you could create a VPC if you like. And the moment you start creating a virtual private, let's see if we have a VPC already. Yeah, there are 2. So I would like to change my region to the California region to match line number 11. This line I want to match. So I will go and stick to that California region, which is what I have right now. And in California, I noticed that I have only one VPC, the default VPC. And as usual, I just ignore that one most of the time, unless I want to specifically use that VPC, in which case I will use that. But right now, we want to create a completely different design, completely different architecture, and we would like to use a different VPC. So we will begin creating a VPC. And the first thing it asks you is the CIDR block. In our previous example, we chose this CIDR block as the block of our choice. So we'll say this is the name of my VPC, and the CIDR block is, the CIDR block is this, not this, but 1000 slash.
Every goddamn fucking thing.
And so,
Go away. Go lay down.
and so that CIDR block is what I intend to use in a previous example that we have done by hand.
Yeah.
So what I will do is, in our example right now, what I want to use is a slightly different CIDR block. It's just whatever you feel appropriate for your design situation, you could choose that. So in our example in line number 16, what we have is chosen a number, something similar to this 128 as opposed to 0. And that's the only difference I have in line 16 versus what we did previously by hand when we were doing it. So slight subtle changes in the CIDR block choice. You can choose any CIDR block that you like as long as it fits the pattern 10.x.x.x. As long as it fits that pattern, you can take whatever you feel like with a /16 at the end. That's the requirement. Because that you cannot go bigger than /16. It has to be, the range cannot be bigger than a /16 CIDR. This CIDR block is limited. That's the Amazon limitation. If you try to go beyond /16, something that is bigger than /16, something like a bigger number would be this, or this is a bigger number. This is a smaller number of IP addresses available inside your VPC. And this is even smaller than what you have when you have 16. And I hope you understand when I go bigger number here, so 20 is actually smaller than the number of addresses available in a /16 are more than what you have in /17 or 18. And that's how the math goes with VPC, with CIDR notation. I think you know this from a previous discussion on CIDR, that's how the math is. So the max you can get is 16. And with that choice, we can begin creating a different VPC by this name, which is this SDF name. In our example, we have chosen a name automated, and we'll see that example as we go along. So what we are doing is collecting all the variables in form of this variables.tf file, specifying a VPC CIDR block like that. And similarly, we will go and create a specific set of subnets for us. For example, in the default VPC, we just have this one subnet given to us. In our example, we would like to have two subnets. One of them will be the public subnet, and another is a private subnet. And we are going to call it out by a range of CIDR blocks. Like this, for example, is the CIDR block for public subnet. And this is the block for CIDR that I would like to have for my private subnet. So I call them out in lines number 21 and 26, like this. And as a consequence, we will receive two different subnets. Specifically, we will have this subnet and this subnet, the private subnet, the public subnet. We'll have these two separately called out because we chose that. We chose the names to be something like, where is that? Yeah, 10.128.0.0 and 10.128.1.0. That's the private. And so we'll draw that in the picture. It will be 10.128.0.0/24. And this is 10.128.1.0/24. So this is the difference in between the two subnets. This indicates a different subnet than this one. This specific position is different. And both of them are /24 CIDRs. The whole VPC itself is 10.128.0.0/16. That's the whole VPC that we have. All of it together is the entirety of the VPC. Inside that VPC, a subset called the private subnet is this range, and a subset called the public subnet is this range. And those two are carved out. And that is what I'm really driving to accomplish by calling them out in lines here. This one is the public subnet. This one is the private subnet that I've called out in form of variable references like this. So I have two variables, one for public, private, and one for the entire VPC. And all of that is going to be my US West 1 region. So I'm specifying variables as I go along. And since I have chosen US West 1, I need to make sure that the machine images that I want to use inside that region are correct. And I can do that by looking up what are the machine images that I have available in that region, US West 1, by looking it up on a public location, something that you probably know already. And I'm going to point it out to you again. Point it out to you again. I think that location is the Ubuntu AMI Finder. And I will go to that location right now. 1 minute. Let me adjust the screen one more time. And I will tell you what I'm going to do next is that I would like to call out the machine images AMI numbers. Those AMI numbers you can get from Ubuntu AMI Finder. And in there, you can go to the Ubuntu AMI locator website. And here you will find at the very bottom, you go select your region of choice. So for example, my region of choice is US East 1. And there I want to select a version of operating system called Precise. That's this 1404 Ubuntu that I have in mind. So I'll select that. No, not Precise, Trusty. Trusty is the name. I have 1404 for Trusty. So I get 1404 LTS numbers. Then I select 64-bit operating systems. So I'll select drop down to 64-bit. And then I want to select HVM, EBS, SSD. There are more other choices. For example, you will select that there are these non-HVM choices. For example, this one is a no HVM, no HVM, no HVM, and no HVM. So there are total 8. And I want to exclude those without HVM, which I cannot do in a simple drop down. But then there are 4 with HVM, like hardware virtual machine HVM. That is one of them. Here is another one. Here is another one. And here is another one. I would like to select HVM, EBS, SSD, as opposed to HVM, EBS with a magnetic hard disk. I don't want that one. I don't want to unnecessarily get a higher expensive hard disk, expensive SSD with a IO1 attached to it. So it's a higher performance SSD, which comes at a cost. I don't necessarily want to select that one either. I want to stick to the hardware virtual machine with elastic block storage comprising of SSD storage. That's the one I would like to keep. So I'll narrow down the choices to HVM, EBS, SSD, click, and I get my choice. My choice of this AMI that I have is available to me now in form of that number. That A22BFA94 is the AMI ID that I would like to have. And I'll copy that and put that in this location. This location, I can change it to this new address, a new AMI number I have. So I can just replace that number 48 Delta Brother 9D 28 with a new number that I have from this website. And I can just replace that if I like, just like that. I'll go strike that out. Say, I don't want you, but I want this. And that is totally okay. However, you will see that there are other values for US West 2 and East 1. So I can choose whatever ID numbers I like. Now, what was that old value and why was it there? And how did that work out the last time? And why did I want to change to a newer value? Well, you don't have to, but you can. The release date of this latest image that you have is the February 22nd, 2017 release of Ubuntu 1404. AMD 64-bit architecture for the name release name Trusty, available in US East 1. That's the ID number that you have. Earlier ID numbers were what I have reserved and saved in that file. They are also correct. They're not wrong. They're just a little bit old. So you can update to the latest version of AMI if you like by pretty much changing the AMI ID number like this. Come on. You can go change like what I just did, like this. If you want to change, don't have to change, but you could. Similarly, if you want to go to US West 2, the other region, this is Oregon, you can just drop down here and say, I want to get the Oregon image. So I can say US West 2. Click. And then I get a new image ID number, 17 Alpha Charlie number 2C77. I can use that image ID. But you know what? All of these things are not really relevant because we are in the US West 1 region. You could change it to another region if you like. In that case, appropriate image ID numbers will be picked up when you start machines. And that is what we can do and we intend to do. And so what I'm going to do is not necessarily change what I have, but leave it as the way it was. And at the same time, telling you that you can change if you like, get the latest updated versions are released for that particular operating system type in a region of your choice. And similarly, US East 1 will be available somewhere here, and you get a new image ID from there. So you could just pick up those IDs and put them in your list of AMI supported. And that is how you start building your list of variables that you want to deal with in the example that we have here. And that is what is going to collect all the variables for your exercise that you will run when you run Terraform. And that's that file containing all the variable definitions. We do not have too many of them, only some variables like what we have here. And now we will go understand what are the key operative files that are there in here that will actually get invoked one at a time when we run this exercise. If you remember this old exercise we did by hand in our first segment, which is cloud technologies, somewhere along the way, module number 11. If you remember, you did this exercise, module 11, and you begin building things by hand that you begin with understanding security groups, subnets, insider notations, masquerading, source and destination checks, creating a VPC, creating a gateway, all those things that you remember did. Pretty much on those lines is what we will do, but this time we will do it by automation, the Terraform automation. That's what you will see happening as we go along doing this exercise, and you will see new things get created and become available in your Northern California region as we begin doing stuff. And so let's begin doing some simple stuff at a time. If you begin constructing something in the Amazon cloud by hand manually, the first thing you would do probably is going to be creation of a VPC itself. So if you close out on this file and look at that file here, it defines your virtual private cloud right there. That is line number 9 through the end. So this resource definition defines a virtual private cloud. And by the way, you can refer to these files directly in source code because you have a Git repository reference that I have pasted in that location. That's what I'm reading right now. In Atom Editor, I'm looking at this particular file, AWS vpc.tf. And that file contains the same thing that we have here in Atom Editor, where I'm defining our VPC. So this is how you begin defining. And now I want to reduce the complexity of this exercise to the bare minimum possible. And what I'm going to do in that, to help you with that, to improve your understanding of what is going on, is to reduce the number of files. There are too many things here to deal with. And I want to cut them down. So I will begin deleting a bunch of things. For example, this file is a file that is here because of a previous iteration. And I want to clean up a couple of things and hide them from view. And so when I do that, it will improve your understanding because lots of things will go away from the screen and will appear one at a time as I basically invite that thing to come. What I'm going to do right now is compare in Git what are my differences that I have changed between what I have in my repository on the internet versus what I am supposed to have when I first pull. So you will see that my Git differences, what I have changed between what I have on GitHub and what I have on my computer. The differences you see are only these two red lines are deleted and the two green lines have been added. That's pretty much it. That's what you notice. The Git difference shows that I have modified something in that repository. Basically, I added my keys like this and this. I removed the change this segment and put my keys. That's the only change I have done. In addition to that, there are a couple of other changes that are not captured by Git that I want to remove. And those two changes are these files. This file, Terraform TF state, and the Terraform TF state backup. Those two files are constructed on March 4. Those March 4 is the time when I first ran that exercise with you, the last session. Today is March 7th. The last time we ran it was Saturday, March 4th. And those two specific files got created because whenever you run Terraform, it leaves a footprint of what is going on. And that footprint is what is captured in those two files. So since we are going to run it again, I want to delete those two files completely so that they will create again. And I just deleted that one file, and I'll delete the other backup file also. You can actually see what that backup file contains. So there's a chat request. The chat is there an automated method of checking the versions and instances names before actually running Terraform? Unfortunately, no, David. No. No, this is a automation tool. The tool itself is not automated. It will help you automate other things. So I think that answers your question, David. There is some work involved to make your automation work the way you want. And it involves due diligence on your part to make sure that your final result is automated. But the tool itself is not automatic at all. Don't get me wrong. No, the tool helps you in automating other things in life. So that's what we...
Can I add a little bit more?
Yes, please.
The reason I'm asking is if you lost your VPC and you needed to recreate it, you'd want to execute this Terraform again. It was 2 months down the road. You couldn't just rerun your Terraform. It's not ID potent, I guess, or
it is going to do that. Yes. Answer is yes. If that is the question, the answer is yes. If you have a VPC and you accidentally destroy it and you run Terraform apply again, it will fix it. It will bring the state you want again, and you will see some of that right now. Live examples, you will see that. If something goes wrong, it will heal it. You will see that happening.
okay.
We'll see live demos. Yes, that will happen. Yes, correct. But checking the version of Terraform itself, no, it is not going to self-update by itself. That's by design. It doesn't update itself unless you want it to update. So let's continue. What I'm going to do is to delete that one extra file that I have, this backup file, and I wanted to actually see it. So that backup file contains, by the way, before I not save this backup file contains the version of Terraform used and the modules used in the last iteration. So that contains information about the last time we ran it. So I'm going to delete that file also. It is not a part of your Git repository, and this was the file that I already deleted. It is also containing information about what we ran the last time, and that can also go away. So now we have only one exact change, which is this file containing these two lines that I modified to indicate our key pair. Now back here, we'll go and check git diff to see the differences. The differences are only precisely this changes to the actual values. Now that we have Terraform ready, exactly how it is on GitHub, with only this change, I would like to further simplify it a whole lot. And for that, I want to make a new folder and hide a bunch of things in there. So that hold folder I have here, this hold folder is what I intend to use to hide stuff. What I want to do is basically take this file here and hide it. this, and like this. And basically, I'm moving these files away from our view so that our exercise really, really becomes simple to understand. I'm moving them out of sight, one at a time. And when I want to run them, I will bring them back in our view. And so right now, our view is a whole lot simple. I have hidden most of our operative files, the green colored ones, inside a hold folder. And I have only the variables reference here, which is simple, and we already discussed that. Then I have some bunch of binaries here that are not immediately used, and we'll use them, but not immediately used, and a cloud config app.yaml, which is what we will use to install Docker on the boxes that we will create, and then run Nginx in a container inside those boxes when they create. And so that is this app.yaml, which is the configuration of cloud I want to inject in the machine I start. But that is also later, not right now. The key operative thing right now, all of them are hidden inside this folder called hold. And so now if I say the variables, I see them. And back in our terminal, if I go and say Terraform, tell me what will you do when you run? And that question in command is pretty much like this. Terraform, what is your plan? And it says, I plan to do nothing. Terraform, what is your plan? What do you plan to do when I ask you to do something? So when I ask you to say Terraform, apply, what will you do? That's the question I'm asking when I say Terraform plan. And what will you do when I run apply? So tell me your plan, please. And so it tells me Terraform plan. It says no changes. I will do nothing because your infrastructure that you have in the cloud is up to date. This means that Terraform could not detect any differences between your configuration and the real physical resources that exist. As a result, Terraform does not need to do anything for you. So since we are hiding everything inside our hold folder, Terraform thinks that there is nothing to do because it matches what you have in your mind is what you have written down in this location, and you're basically hiding everything in the hold folder. So it doesn't see those things in the hold folder, and it will believe that you have nothing to do. So it will do nothing because it matches your intention, which is blank, with the cloud, which is also blank. So blank matches blank. I will do nothing as a result. You see that it tells you I will do nothing, and that's nice. But that's not what we really want. We wanted to do something, and so we had to express our desire in form of .tf files that are currently hiding in this folder. And so if I want to bring my desire and express that to Terraform, I have to pull that file out into our real operative folder. So I will do that. What I will do is I'll pull one of the files here. For example, let's go see if we have a key pair file. And that's the first thing you would probably do is, get a key pair and put that in the Amazon cloud. And our key pair file is this file we have, sshidrsa.pub. That's the public key I want to give to the Amazon cloud. And I want to choose the name, key name, automated VPC. That's my intention. And so I will also cross-check my intention with the Amazon cloud. And let's go see in the Amazon's cloud, do we have in Northern California, do we have a key pair by the name automated VPC? So we'll go EC2 and see the key pair. We have key pairs, and we don't have any in the Northern California region, which is nice. So it is blank. Now let us express our desire. Our desire is to have a key pair. And so we will get that key pair.tf file out of the hold area like this. And now the hold area does not contain key pair, but it is outside. And in that outside location, we have this desire expressed like that file says. I would like to have a resource called AWS key pair created with this key name automated VPC, and the file public key, which is sitting in our .ssh folder by that name. That's the public key I would like to use. So please Terraform, go here in that location and use that public key I have here and give it to the Amazon cloud in the US East 1 Northern California region and call it automated VPC as the key name. That's what I would like you to do, please. And so I express my desire. And I would like to ask you, Terraform, what is your plan? And so here it says, this Terraform plan that I have, provider AWS region, the region where AWS operations will take place. The examples available are US East 1, US West 2, etc. The default value that I have chosen is US East 1, which is the default. And if I if I do not override this value at all, it will automatically go and do whatever it is supposed to do, and at least tell me the plan of what do you intend to do when I run apply. Give me the plan. So it is going to generate a plan for you based on the default values. If you do not type anything else here, I'll just type enter because that's the value I would like to choose, which is default. So I'll just say enter, and it generates something different. And it tells me no valid credentials found. I think I have a key pair problem. So let's go see what's going on. So it says error refreshing state, one error occurred, no valid credential source found in the AWS provider. I thought I gave you the credentials. Please see this resource for more information. I think I may be missing one more file here that needs to be out. Okay, I think we need to have this AWS VPC file also out because it defines the actual value of key and secret and the region selected. That segment is necessary to express. We are hiding it right now, which means that file called AWS VPC, which actually defines those credentials, is in this line number 3 and 4. And I'm deliberately hiding it in the whole folder. So I need to bring not only the keypairs.tf file, but also this file outside. And you see what I'm doing and why I'm doing it, because there is a dependency on that. So my desire is expressed only partially. When I say I give you key pair, but I don't tell you where exactly to go and put those key pairs and what is the credential that I would like you to use. And that credential is actually defined in this file here in line number 3. And the region is defined in this region line number 5, which is expressed in form of a variable in variable.region. And that value is defined in the variables.tf file, which is here. And that variable.region is here. The default value is US West 1. And given these values selections, I'm now able to run the plan command one more time. Terraform plan, show me what your plan is. And so here we go, clear the screen and show me what your plan is. And so it goes to the cloud, matches whatever you have in the cloud with whatever you have in your expression of desire in the local folder. In our local folder, we have expressed 2 desires. Those 2 are this file here. I would like to have a key pair and a region selection and also define a VPC. That's one file here. The VPC has to be created using the VPC CIDR we have called out, and it has to have DNS host names enabled true. It has to have a name called automated. And then the other desire I have is this. In that desire, I would like to call out that my key name has to be this, and the key file has to be this file, idrsa.pub. So these 2 files express my desire together. If I attempt to go with just the key pair desire expression, then I'm not telling this Terraform tool, where do I go and run that? and what credentials do I use to connect. And therefore, in the previous run of the plan, it failed on us. If I run it again, it tells me the plan. The plan is what we will read next. So it goes to the cloud and says, you know what? There are these two green lines I will do. The green line is a plus sign here and here. The plus sign indicates that there is a difference in what the cloud has versus what you have in your desired expression. One of the first differences I notice, and that's what Terraform is telling you, Terraform says, I notice that I need to go and create this resource, which is basically telling you that I need to go and create a new key pair with a fingerprint that I will calculate on the runtime. The key name is going to be this, and the public key value is going to be this expression. Where did this expression come from? It comes from here. Oh, sorry, I should say cat. I should say cat, not ls. And so this expression comes from this number here, this sequence number here, this sequence SSH RSA that matches this expression pretty much item by item. You can see that Q8KZ and Q8KZ match. So that's the public key that it picked up from your local location, this location. It also picked up the name automated VPC. That's the name that we have decided to give it by this reference here. And it says that it is going to create a key pair like that. In addition to that, it also tells you one more thing. That thing is, it tells you that I want to create something called a VPC with a default CIDR block that you have defined already. I will conclude that you need a network access control, you need a route table, you need a security group, you need DHCP options, you need enable classic links, enable DNS host names, enable DNS support, tenancy, route table ID, tag, and tag name. All of these things, I will construct it for you. And some of these variables will be runtime computed. We don't know the things, ID numbers for various resources yet. So they will be dynamically generated by Amazon and given to us and assigned here once we run it. So right now, it is a plan stage. So we are seeing the plan. We are asking Terraform, what is my plan for the day? And Terraform goes to the cloud, finds out that you have those two things that it needs to create for you. And so when you say Terraform apply, it will go and do those things right now. So if you go back to Amazon's cloud, you will find it does not have a key pair. And also, you will find that it does not have a VPC called automated. You have only one VPC, and that's the default VPC. So I want to create these two resources, the key pair and the VPC, and I'll say, go and apply, please. Go do this for me. So it goes and does it. It will go do two things and come back and report that it did. So it is doing those two things right now. First thing first, it says, I'm going to create a key pair. And then it tells you what it did. Then it says, I'm going to create a VPC. And it creates that VPC for you and comes back and says that creation complete. Then it summarizes the two things that it did, apply complete. Resources, there are two added. Nothing changed and nothing destroyed. And that state that you have created has been captured in this file, terraform.tfstate. A new file got popped up here, that file. It shows the current state of the cloud. This is the state of the cloud file, effectively. What is the state of the cloud? Is that's the state. We'll go read that detail in just a moment. But I want to quickly go and check my cloud and see what do I have. Do I have a VPC here? I'll go refresh. And I should see a VPC popping up right there if I refresh properly. So refresh, and there is my VPC called automated. And it is available with the CIDR I have chosen. It has the tag name selected. And it's just a VPC with nothing much. Nothing much as in it has a subnet available to me by default. Let me see, filter by the automated VPC. No, we do not have any subnets yet. Do we have a route table? Yes, we have one route table given to us by default. And that is this route table that I don't intend to use, by the way. So I will like to maybe label it that I don't want to use it. This is the default that got generated. So we'll not use it, by the way. I'm just labeling it as default for automated. And you will notice that we are not going to use it, by the way. And so that default for automated was given to us by default. Let's see if we have a gateway. No, we don't have any. Do we have egress only internet gateway? No, we don't have that either. Do we have DHCP option sets? Yes, we do. And that's also given to us by default. And you can see that the details, the tags that we have been given to us for this automated VPC by default. There are no elastic IPs. There are no endpoints. There are no NAT gateways. There are no peering connections. None of them is given to us. What you will now see is if you go back and look at EC2 section in the California region, you will see that there is a key pair now. The key pair is the automated VPC key pair that got created because we desired so. We said we would like to have a virtual box. Says that we created a key pair. That was our desire. So the desire shows up right here. So give me an automated VPC like that. A key name and a public key that got created because you expressed the desire. So up until now, we have done two things: expressed our desire for having a VPC created and having a key pair inserted. Both these things were taken care of. And now let us bring out more items from the hold area into the main folder, one or couple at a time, and see the change in plan as it builds. After you construct a VPC, you would like to have some subnets created in there. And you will remember that it's easier to create a public subnet because you can just make a connection with the public outside internet by just connecting a gateway fairly easily. But creating a private subnet actually requires you to create a subnet association with a NAT device that has to be there, and you have to create a NAT device also, and then use that NAT device to allow the traffic on the machines inside, like these boxes. You would like them to go to the outside world using a NAT device, and then connect to the world outside like that through the NAT, and the NAT goes out. Whereas any boxes that you might have in your public subnet, they should be able to connect to the world outside using a gateway, like internet gateway you will have, which is like a straight connection to the world outside. That connection is easy to establish. So the public subnet creation part is relatively easy. The private subnet creation part requires that you have a NAT device to begin with. And so we will have to first create a NAT device before we create a private subnet. Otherwise, it will fail. That saying that you don't have a NAT gateway to go out, and this private subnet is not really private. So I hope you remember what I'm talking about from a previous exercise that we did. We had a NAT device, and then we used that to establish a route to the private area. And that is exactly what we are going to show in this example by focusing first on a public subnet. So we have a public subnet defined in this file. And what I would like to do is pull that file out from the hold area here. And now we see that there are three files: the public subnet, the key pair, and the VPC. That's our desire now, showing three files, and that's what they mean. But let us ask Terraform, what do you plan So it is going to go compare what do we have right now in our folder, and will tell us what it's going to do in the context of the cloud. So it goes and sees what the cloud is, and it finds out that the cloud already has a VPC. So it just refreshes the state. It gets the VPC ID. The cloud already has a key pair, refreshes the state. The name happens to be automated VPC, that's the key pair. And so it attempts to generate a plan. Plan has been generated, is shown below in alphabetical order. And green resources are going to be created. Red resources are going to be deleted. And cyan entries are the data sources to be read from. And so since we did not specify an out parameter, you can actually save this output in a file if you like. And so the idea is that it tells you that it is going to generate a new internet gateway. That's one thing. That came out because you called it out, like here in the public subnet Terraform file. You express your desire to have a gateway created. That's in line number 2 and 3 and 4. So you say, I want to get a gateway, please. So you say that resource, AWS Internet Gateway, give me one. So it gives you one like that. And that is going to be this ID number. It also further says that I need to get a route table created. And so you call that out in first, you actually describe that I would like to have a public subnet first. That's what this file says in line number 7. Create a public subnet. In that public subnet, you specify that it depends on internet gateway in line number 12. And that is this line. Line 12 depends on a gateway that you already have created in line number 2 here. And that is already there for you because that's what this will create for you. And then in the lines number 12, you will see that a new gateway will be used in this public subnet, which is going to get constructed in line through 7 through 16. It will have a name called public. It will be created in the availability zone US West 1A. And the VPC ID will be chosen dynamically based on whatever VPC ID was already created, and that ID number happens to be this, is what was generated by default when we ran the previous attempt of Terraform apply. You created this VPC here, and that is the VPC that got created, called by the name automated. And that is what we are referencing in the public subnet. We are saying that use the VPC that we have already, use the CIDR block that we have defined in the variable file, use the availability zone US West 1A, and being a public subnet, I would like to map any machines that you get created in this public subnet to have them dynamically assign a public IP. So what does that mean? In a box like this, public IP, yes. Box like this, public IP, no. That's what I mean when I say this map public IP on launch true. Because I would like to get this box in the public subnet to get a public IP so it can connect to the internet gateway and go outside without problems. Whereas not the case in the private subnet. You will notice that the other file, which is still in hiding in the whole folder, contains map public IP on launch false. You will see that here, which is currently hiding in the private subnet. It says map public IP on launch false. That's the hidden file right now in the whole folder. We are hiding from it, hiding from Terraform right now. But the public subnet is what I want to construct first. What I want to do is have this public subnet associate with a routing table called public route table. And this route table needs to be able to connect to the internet anywhere on the internet 0000/0 using the gateway that we have created here. And that gateway is what I'm referencing in this gateway ID. And that is what I want to use. So I'm going to tell Terraform, when you create a public subnet, please also create a route table which uses the gateway that I have created here. And then associate this public subnet with this route table, associate this route table with this public subnet. And that association between this block of code, which is the subnet, and this block of code, which is the route table, I want to associate these two together by doing this association. Associate the routing table to the public subnet, and that association happens pretty much like this. Resource AWS route table association between the subnet ID, which is this subnet, and the route table ID, which is this route table. And you're calling them out line by line, and that's what Terraform is able to read your desire and is able to generate an internet gateway, generate a public route table using the internet gateway that you specify here, and also make an association between your route table and your subnet. And the subnet that you will create will be in the availability zone 1A. It will assign public IP on launch true. It will be tagged the name public, and it will associate itself with the VPC ID, which is this ID, which is what you have already created. And that is the plan. With this information given to Terraform, everything else currently hiding in the old folder, I've expanded the creation of these four things: a gateway, a subnet, a route table, and the association between this route table and the subnet. And that's the association. And you will see these four things happen: gateway, route table, association, and subnet happen, execute when I run Terraform apply. It will take the plan that it told you based on what you describe as your desire. So your desired expression happens in the .tf format. This format is available in documentation in Terraform website. You can see that here somewhere. In Terraform website, lots of documentation available on how do you write those .tf expression of desire for a variety of providers. And for example, Amazon, you write it like this. There are examples after examples of how do you write your desire. How do you store credentials? How do you use them? How do you share credentials? How do you perform a variety of resources? And this is, by the way, available for a variety of clouds, not just limited to the Amazon cloud. It is available for a bunch of them. You will have references to, where is that, OpenStack. So you could use Terraform to configure OpenStack if you decide to go that route. That's the direction to use. And there is extensive documentation available on how can you use OpenStack, your internal private cloud, and configure it with using Terraform, which is also open source. And that's the examples that we are going to run. So when I run Terraform apply, I expect to have these four resources created: gateway, public route table association, and a public subnet. Do I have them right now? No. Let's go confirm that I don't have it. So in my Northern California region, in my VPC, I currently do not have a subnet called public. I currently do not have a gateway. Filter by automated VPC. I do not have a subnet, do not have a route table called the public route table. I do not have a gateway either. And I do not have any association between the non-existing subnet and the non-existing route table. So I will create a route table, create a subnet, create a gateway, connect them together, all of that in one shot, because I wrote that in this expression of my desire in this way, and then ask Terraform, tell me the plan. So it tells you this plan, and then you say Terraform apply, and it applies it for you. So it will just do the things. It'll do these things and come back and tell you that it did. And so it's doing it right now. So it tells you that it did. What did it tell you? It says Terraform apply, and it tells you that 4 resources were added. So I said, okay, great, let me just see it. So back here in our automated VPC, if I go refresh, I should see that a gateway got created and attached to the automated VPC. That is good. Now let us see if we have a subnet created. And yes, we have a public subnet created. This is exactly how we wanted it to be with this CIDR block 10.128.0.0/24. Automatic assign public IP, yes. Route table association, this one. Let's go see the route tables. Route table, there is a public route table created right now for us. That is this one, not the other one, this one. And that is the one that got created. We can see that it has a route to the internet using the gateway that we created here already. This is the 7Fox1 Charlie gateway. That route table has a route to the internet using 7Fox1 Charlie internet gateway already. Now, having seen that route table selected, we'll also see that this same route table has been associated with the public subnet like that. It's already associated with our public subnet that we created here using Terraform. So we are seeing those things happening as we go along, and we are seeing that it has constructed more resources for us, and it is capturing whatever it is doing in this file here. And let us go read that file. Excuse me. Let's go read that detail as to what it is trying to capture in that file, which gets generated dynamically. And so be very careful in dealing with that file. You don't want to make edits to it. It is managed by Terraform for you. And so you don't want to mess with it. This is the record of Terraform as to what it has done for you up until now. And this is how it keeps track of what is in the cloud versus what is your desire. And if there are any differences, it will go and make those changes for you when you run Terraform apply. And so that is what this is the file. This is the plan of record, by the way. This is the state of your cloud. So if you see this file, it is a long, big JSON file. If you keep scrolling through, you will see that it has up until now 148 characters, 148 lines with references to a big block of code here. Well, this is not code, this is JSON. A big block of JSON that says AWS VPC constructed, like that, all of these things. You will see further another block saying a subnet constructed, another block saying a association between route table and your subnet constructed, the public route table associated with the public subnet. You also have a route table creation, subnet creation. That's exactly what we did. It is writing that down in form of a JSON. And you have a gateway created, a public key inserted called automated VPC, public key. That key pair is inserted. This is the public key pair value, public key value, the key name, and a VPC created, internet gateway created, and the version of Terraform used, 082, and corresponding details. So you don't want to mess with this file manually. You would rather have Terraform manage this file for you. It is the state of record as to what Terraform has done for you up until now. And at this stage, you will see this idea that I'm really trying to accomplish is what I'm doing is this hold folder. I'm hiding stuff from Terraform for you to simplify our understanding of what this tool does for us. And so let us now go back here and grab one more thing. Like I want to get something else added to my cloud from a security standpoint, from an access control standpoint. And so what I want to be able to do is make sure that I define certain security groups. And that is what I have done in this security groups Terraform file. I'm basically defining a collection of security groups, and I want to see those security groups in play. And so my idea is to move this file outside of the hold area and put it there. Now that I have it outside, this file showed up in this location. And in that file, I will read what it contains. What it contains is my desire of expressing the types and number and variety of security groups with access control policies for every group that I have called out. And in here, it's probably the longest file I have. It's like 81 lines, 82 lines. And in there, let's go see what it contains. This contains, by the way, before I describe this, I want to just quickly check Terraform's plan of what it intends to do given this new file added. So Terraform plan. Tell me what is the plan? What is it that you will do when I run apply? So I'll say, tell me the plan. So it goes to the cloud and compares with what you have in your desire and tells you that it is going to create a bunch of things for you. And those 3 things it will do, 3 things to add. It is not added yet, but it is planning to add 3 things. What are those 3 things? It needs to create 3 security groups, by the way. It needs to create an AWS security group called Web. It also needs to create another security group called NAT, and one more security group called Default. 3 security groups. That is what will be added when you Terraform apply. And what are these 3 security groups? It is describing that to you right here, right now. And it tells you that for the web security group, it intends to open port number 80, port number 443 from anywhere on the internet, so that people from the outside can connect using these 2 ports, 80 and 443. And that is the security group for web traffic that allows access to port number 80 and 443. And so as a consequence, you will see that you have people on the internet. Let me erase this again. So I'm going to erase that. So the idea behind security groups essentially is to allow access control, allow appropriate traffic to flow from A to B, whatever that is. And you need to define it very succinctly. And that is how you do in a context of security group. So the first thing you would want to do is to have these people, outsiders, customers, you would like them to come in and visit your services. They will go through a load balancer. And that load balancer is where your services will become available on ports number 80 for HTTP traffic and port number 443 for HTTPS traffic. And that's what we are basically doing in the web security group. I would like to have these ports open. That's what I have defined in this location, but I'm saying that in my web security group, I need to create a security group called Web Automated VPC. That's the name. And the description is in English language. The VPC ID will be the one that I have created. Allow ingress, incoming traffic from port 80 to port 80, protocol TCP, and allow from anywhere on the internet, let people come in. Same thing, repeated with a different port, 443. From port 443 to port 443, allow traffic, TCP, from anywhere on the internet. those two rules essentially with a tag called web automated VPC is the tag that I would like to use, and a resource created with the name web automated VPC. And that is a security group I want to construct. And so that's how you describe your security group. You do the same thing in Amazon's console or any other company's console to create firewall rules, security group rules. Basically the same thing. You allow allow traffic. So this is the web security group. Very, very similar, but different ports and different permissions for the next security group called NAT security group. This NAT security group is going to be a different one that allows specifically you, not random people on the internet, but you, the administrator. You will be allowed to come in to your boxes that you manage. And this is your, say, for your example, your NAT box. So you would want to come in through the NAT, go in here, or here, or here, or somewhere else, like here, inside your cloud. You would like to have a method, a systematic method that allows you to come in. And that requires a separate group, a separate security group. Is the load balancer also the Bastion host? No, 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 no. Load balancer is strictly for people like outsiders, customers to visit your, so oops, not that line, to visit these guys and this guy. I should change the color. It's a very, very different thing. So you should have these people connect like this. And this is where your web servers are. And the load balancers function is to allow people, customers, to get balanced across multiple web servers to balance the load. The load comes from people hitting your site. People are hitting your site. You want to balance that load across multiple machines, multiple boxes. So you go like this, and you balance the load across a bunch of them like that. It has absolutely nothing to do with connectivity for network address translation. Let's read the question again. Is it also the Bastion host? No, the Bastion has to be separate. It is, by the way, not a host. It is just a balancer that balances load for the customers. I hope that is clear. If not, let's make it clear. It has absolutely nothing whatsoever to do with Bastion role. Bastion function in our example will be performed by this guy, which is our NAT device. It is also known as the Bastion box. It is also known as the jump box. It is also known as Jumpo box. No, jump box. So that's what these things is going to be used. And in our example, we will today introduce another concept, which is basically where we don't have to have these things. And we will just logically place ourselves into the cloud magically. And this magic is actually not magic, it is logic. We logically place ourselves into the cloud by using virtual private network. We will do that. It is built into the exercise. You will see it happening, and you will see yourself logically placed inside that VPC by using a virtual private network. Many of you, by the way, today already use this thing in your company, very, very likely. And I know Boeing does. I don't know about other people's companies, but very likely you have a thing called a VPN that when you are in your home and you want to connect to the workplace, you would use something like that. And that thing is called a VPN connection. You probably have it already in your company. You have to VPN in order to get inside the company. We'll do the same thing in our example, our NAT box is also running a VPN. You will see that, and we will establish a VPN connection at some point as soon as the exercise completes. At that point, we will be able to connect from our location inside. And in that situation, you don't even need a bastion or a jump box at all. You can just arbitrarily connect. Being you, the super powerful admin, you can logically place yourself. So this is physical you, and this is logical you. And you will be in the cloud inside there with an IP address in your VPC. You get a VPC IP address in addition to your home IP address or your office IP address. So you have another IP address given to you by the cloud because you logically place yourself in a VPN, and you will see that exercise is coming up for real. We'll have a VPN set up, and you will connect to that cloud using a VPN connection. That is what you will see happening, and it's there as a part of this exercise. So, but yes, good for clarification that load balancer is not the bastion; it's a different item. Okay, let's continue. So, erasing all this.
Yeah, Nilesh, just a question.
Yes.
So if you want to do some sort of API management, then would you be doing that on the load balancer, or would you have something different for API management, like like using like something like layer 7, or to have policies and all that stuff?
Yeah. I'll answer that.
Yeah, like a proxy.
So there are two things. One of them, you said, is API management. And the other thing is API usage. I would like to clarify who is the user, who is the manager. A manager for an API would be somebody who writes code to make the API work. So that manager will manage your API, whatever that management means. You have to define what management is. A typical API user is a machine that makes an API call. A machine that this person has this machine. This machine might run an API call. That API call will have to go through this on port number 443. HTTPS. That's how the API call will happen. If this person is running the API call as a user, the API call has to go through the load balancer into the cloud, into your machines that actually service the API call. And that's the API usage scenario. Now you have to explain to me what is API management. And if you are a manager, or if you're the developer of the API, you need to manage your API, whatever that may mean. But essentially, you get full access to the machines directly. And in that situation, you are messing around with the box, messing around with your code that you will write so that the user can make an API call. And that is how I would differentiate between API management and API usage. A user will come from the load balancer. You will go wherever you feel like. It's your cloud. So you could logically go there and do whatever you like, as long as you're not physically there, because you cannot go physically to your cloud. It is not possible. You can logically go there, absolutely, by using a VPN connection, or maybe a jump box, NAT box, bastion box, and all that. You already know the jump bastion route. I will show you the VPN route also today. So let's erase that and continue what we're doing, which is to make sure that we are able to. Where is that thing? There's too many windows. Oh man, go back there. Here. Yeah. So in our security group, we have defined a web security group. We are also going to define a NAT security group, which is going to be responsible for the security policy for our NAT devices. And that begins at line number 27, goes all the way through 57. And that is going to be this segment all the way up to this point. And that segment defines a couple of things. You will see that it defines ingress, line number 34. Ingress, 34 line says, allow ingress for SSH access. 22, port number 22 is for SSH access. It says, please allow ingress on port number 22 as long as it comes from anywhere on the internet. So anybody on the internet could, in principle, connect to the SSH port 22, provided they have the corresponding private key. Not everybody has, only you have and I have a private key. Everybody will have your own private key. So you can, as long as you have a private key, you could connect to the NAT, to the devices inside your VPC that belong to the NAT security group. You could connect on port number 22 using TCP protocol, using the SSH software. That's what this segment says, 34, 35, 36, 37. Allow ingress, port 22. Another segment allows ingress, and it's a different port that we never discussed before. And that port is 1194, and it is responsible for VPN connectivity, virtual private network. And this ingress allows a VPN connection to be established between the administrator's machine, specifically something like you. So you have an office and you are in your workplace, or maybe you are in your home, or maybe coffee store, wherever you are. It gives you access to 1194 port on UDP protocol, and that's how VPN connections are going to run for us. You can change the port if you like, but the original default design by this software called OpenVPN uses port number 1194 UDP. That's the, not UPD, UDP. I am dyslexic, UDP. So it uses this port. This OpenVPN, open source VPN software uses this port on that protocol to establish a VPN connection. That is the reason why our description here opens up port 1194 UDP. And you can connect from anywhere on the internet, wherever you are, home, office, coffee store, or just about anywhere else. You can limit that if you like by reducing these numbers to a focused subset of the internet, such as your subnet in your office, for example. So something like, there's a question here. The question is, should we do a short break? I think it's a good idea. Yeah, thank you for reminding. I'll take a short break in just after this discussion about security groups. The group we have, the last one is a default group. By the way, that NAT did not finish. There's one more thing to NAT, and that is to allow outbound access, egress from 0 to 0, and any protocol allow anywhere on the internet. Let people go out. Let our machines that we have in here, these guys, let them go out through the NAT. Out. Let them go. That's what egress does. And that's what you're defining in the NAT security group. You're saying that let these guys go out, any protocol, any port, just let them go. Egress, permit everything. And that's this NAT security group. The last one is your default security group. It applies to anything that you have that is tagged as the default. And the ingress rules allow everything, any port to any port, any protocol, provided self equals true. Self equals true basically means, it means allow any traffic between here to here, here to here, here to there, there to here, as long as it is all inside the VPC, all in there. Any to any traffic is okay as long as you are family in the VPC. Inside VPC, yes, you can talk any protocol, any port, everything is open to you. And that's the default security group. And that's what we have defined here. Allow any to any traffic as long as self equals true. And egress, let anybody go outside anywhere they feel like. 0, on /0, meaning anywhere on the internet, you can just let them connect. And that's the default security group. And that's the description of these three groups: default, NAT, and web, that we have defined. That file description is in the security groups.tf file. And we have asked Terraform plan to show us the plan. It tells us that the plan is going to be adding 3 security groups, and they are here, 3 to add. And after the break, we will add them, and we'll continue our exercise as after the break. So we'll take a short break, timer 10 minutes, and off we go. So I am going to walk away for 2 minutes, and I'll be back. I think I got that. Let me also get the door. That noise was irritating, but I guess that's how timers are. Timers are supposed to be irritating. I think you guys are back. Let me just make sure that you are back. Checking status. Let's see, where are you? Do I see you guys? Oh, you're there. Yeah. So I see all of you are here. And we should continue. So what we were discussing was this idea of using a file like this to describe our intentions to basically, hey, just a quick check. Can you hear me?
Yes, I can hear you.
Yes, we can.
Yes.
Okay, good. Because I don't want to keep on speaking and assuming that you are hearing me. So, these three descriptions that we have are going to create 3 new security groups in our cloud. You should be able to see them as a consequence of a run. When I say Terraform apply, I should be able to see that. When I say apply, I should see 3 new security groups pop up somewhere in the Amazon's console. I should see currently my security groups in EC2 here. EC2, my security groups I have are one for the default VPC, which is for the default that you get by default, everybody gets it. And this one is the default security group you obtain when you create a VPC. This is your automated VPC. So every VPC probably gets a default security group, and the rules provided by default are all traffic allow everything to connect to everything else, provided they are communicating internally to itself. And that is this EB1A, which is the source itself. So as long as your traffic originates from something inside the VPC, you allow it to connect to anything to anything, any port, any protocol, all traffic allow, provided the origin is in the VPC itself. So it's like all in the family, let them talk. That's the inbound rules by default given to us. In outbound, allow all traffic to go any protocol, all the port ranges, anywhere on the internet. Just let people go connect to the internet if you like. Those are the default characteristics provided to us by default for a VPC that you get one default security group that is structured like this. All inbound connections, all internal communication allow. External communication not allowed. Outbound communication allowed. Go anywhere you feel like. That's the beginning point. When you create a new VPC, you get one of these guys. I have 2 VPCs right now. So I have 2 of these guys that I'm not going to use, by the way. These are not the ones I will use. I should actually call them do not use. And even that one, I'll say don't use. So just don't use them. I'll create 3 for ourselves. When I run Terraform apply, I will create those these 3 things for ourselves as we have defined, and you will see them getting created and creation complete, 3 added. And now you can go back here and refresh, and you will see 3 new security groups. This is the do not use, another do not use, so we don't use them. But these 3 that I wanted, one of them is our own created default automated VPC, our web automated VPC, our NAT automated VPC. The web rule allows for inbound access for HTTP and HTTPS for any customer on the internet, anywhere on the internet, let them come in, inbound. Outbound, there are no rules. This is strictly for inbound communication for people on the internet, customers to come in on HTTP and HTTPS traffic on basically anywhere on the internet, global customer base, let them come in. Our NAT security group is a special one where we allow SSH access to ourselves because we have the private key. We can connect using SSH and we can be anywhere on the internet. As long as we have the private key, we can connect to the NAT security group, to the devices inside the NAT security group. And one more rule, custom UDP rule. This UDP rule specifies port number 1194 as the protocol being UDP, and this port allows us to connect our VPN connections to our virtual private cloud, the VPC, the automated VPC that we have built. We will use a VPN connection to connect to our VPC. Specifically, we will be using OpenVPN. OpenVPN is an open source VPN software available here. And you can go to the community section, and that's where you will find the open source segment. And you can also find a lot more documentation and the actual download in this location. And you can download the source code for it. But the best way to run OpenVPN is actually Docker. So you should be able to get Docker OpenVPN, and they'll give you ready-made VPN solutions. So we'll probably use one of these types. So there is a Docker container available. We can just run it by saying Docker pull. And this person, Kyle, has already created a container for us. This gentleman has created a OpenVPN container for us. I mean, an OpenVPN Docker image. So that's the easiest way to run Docker and running OpenVPN for our example usage. And I recommend using that way. It makes a whole lot easier. And so we'll use something like that, something very similar to that. And that is what is my recommendation. If you want to run OpenVPN, I recommend running it in Docker containers. Having said, we have 3 security groups constructed. They look like these 3. So the third one is this automated VPC, which allows inbound connection any to any as long as it is inside the security group, inside the default VPC security group, which is this F909, F908. As long as you are a part of that security group, you are welcome to communicate any protocol. All port ranges open for you to communicate for the family. If you are in the family, you're welcome to talk. Outbound access, every traffic is allowed. You can go wherever you feel like on the internet. So those 3 security groups got constructed. We did that through Terraform by providing a description, our desire in this format. And we are now going to the next step, which is to pull more elements from here. There are 1, 2, 3, 4 things still left. So I would like to now bring out one more item. What I want to do now that we have a public subnet already, we have some security groups defined already, we would like to now see the missing elements. In our picture, you will see that we have, where is the picture? Picture, please. Okay, there is the picture. So in our design, what we have done, let me erase some of these guys. Or what we have created up until now is these things. So we have a public subnet. We have a VPC, some security groups defined. We have a default security group, a NAT security group, and a web security group. We have defined these 3 groups. We have defined a public subnet. We have created the entire VPC as such. VPC created, route table created, this public subnet association established between a public route table. That association has been established. What we do not yet have is the other remaining things which I would like to have, which is I would like to have a NAT device. And once I have that NAT device, what I would like to be able to do is create this private route and a private subnet and a route table, and then allow these devices to connect through the NAT to go outside. That's what I would like to have. So before I create a private subnet, I need to have this NAT box going up and running. I need to do that. So that is what I intend to do here, is pull out this NAT server file and move it out of the hold area into the main location. And so now we see that this new file is now available to Terraform, and it describes our desire. Our desire is to create an instance, a NAT instance specifically, in the region that we have chosen, which is, our region is US West 1. I would like to use a machine image that is defined in our variables file for the variable region we have chosen, which is US West 1. The AMI ID number 1, AMI ID will be picked up from the variable definition here. And that is, this AMI ID will be picked up. And this US West 1 region will be picked up for our example in this NAT server creation. It will say that I would like to have a machine image defined in the variable file, an instance type of T2 micro, go cheap, not too expensive. It is almost free for most of you. It is not free for me, given an old account. Your accounts are probably new. So first year usage is free for T2 micro, 1 full year. I'm going to select the subnet, and I'm defining that I would like to use the public subnet ID because I would like the NAT to be created in the public subnet. I would like to select my security groups for the NAT device. And I would like this NAT box that I'm going to create at T2 micro using the machine image that I have selected, Ubuntu, plain vanilla Ubuntu right now. It is not even a NAT. It is just Ubuntu. So I have to create that box, convert that into a NAT device. I'll do that in the next step, actually right in this file. And I will show you how to convert a plain vanilla Ubuntu box into a NAT box with just one line of code. And that is what we'll do. But before that, I want to assign a security group called default and a security group called NAT. So these two security groups are associated, the default security group and the NAT security group associate with this new machine that I'm going to create. It is going to create in the region using the machine image of site T2 micro in the public subnet, using the deployer key that I have, using the default security group and the NAT security group, two security groups, the key that I have given, the key name that I have chosen, and I would like to disable source destination check, make it false, because my intention is to use this device as a NAT device. So that is one of the requirements that you remember from previous exercises in module number 11 in cloud technologies, is that you have to actually go source destination check disable. And that's what this thing will do for you, is it will disable the source destination check only on this one machine. I will tag it as NAT. And then establish a way to connect to this box, the T2 micro box I'm creating, with a user called Ubuntu and a key file that I have locally placed. This is the private key. I will establish a connection using that detail. And once I connect, I will do a remote execution of some commands inside that box, this T2 micro box running plain vanilla Ubuntu, and I will convert that box into a NAT box. You can convert any box to a NAT box by doing one simple rule. One simple IP table rule defined in line number 19. That is the one line that makes or converts a regular machine into a router. Literally one line, and that line is line number 19. That is worth discussing, I think, a little bit. So I will describe that to you a little bit like this. What I'm going to say is that line 19. So basically, you take any computer, any Linux computer, and it has to have two Ethernet cards, Ethernet outside and Ethernet inside. You connect this to the Comcast cable modem you have, or Quest communications device, or some other internet company. Any computer that runs Linux has 2 Ethernet cards, plain vanilla Linux, any Linux, and make one line change, and this thing becomes a router. And that change is line number 19. And so it looks like this suddenly, with this thing that the yellow connector, internet connector, and 1, 2, 3, 4 Ethernet connectors. These connectors basically are what you are attempting to build when you have something like ETH 1, 2, 3, 4, like that. If you have a machine with like 5 Ethernet cards, it runs Linux, you want to convert that device into a router, you can by doing one line change. One line change, and that change is line number 19 in this location. Line 19, you're doing this change. Specifically, if you read that file very carefully, what you're really doing, I'm going to copy it and make it bigger and take it outside here. What you're doing is you're sending the number 1 and sudo t. T is a way to t the output. So you should study t separately. But essentially, you're modifying this file and writing the number 1 in that file. That's it. You write number 1 in that file, proc sys net IPv4 conf all forwarding the value of 1 in that file makes a machine a router. That's it. That's all it takes to build a NAT device. That's all it takes to build a router. So that's what we will do. And what this does, what it does essentially is to read that line again, this line, it basically allows IP forwarding. IP forwarding says 1. 1 means true, meaning yes. Allow the IP traffic to be forwarded. That's what NAT does. And that is what we intend to do in this one line, 919. And doing that through this software called IP tables. So if you read that entire inline segment that we want to remotely execute using these credentials, Ubuntu username, this private key, connect to the remote machine that you are generating here, and you remotely execute this segment of code in line only up to these 2 segments. They will create your NAT device already. That's it. The next lines installs Docker. The next line after that installs OpenVPN in Docker. So what you're looking at is these lines, actually these 2 lines construct creation of a NAT device. The next line, line 21, installs Docker. And then 23rd, line 23, will create a folder for OpenVPN and run OpenVPN inside Docker and generate OpenVPN server configuration again inside Docker. So those lines are long and complex, especially the OpenVPN one is a little bit complex. But I will read that and explain to you when we run it. And so we'll be able to make a VPN connection between our cloud and our local location very, very easily, because we have these lines execute and run OpenVPN installation in that NAT device itself. So our purpose of that NAT, we are going to create, where is that NAT here? So this NAT device that we will have will not only function like a NAT, but also function like our VPN connection to the cloud. And that is what we intend to run in this segment. We are basically preparing our groundwork to create a private subnet. We don't have one yet, but for the private subnet to exist, we need to have a NAT device so that we can route traffic properly. And we want to really create this thing, but it requires this thing. So we are going to create a NAT device. And while doing that, we will also run OpenVPN right here. And having an OpenVPN server running in our cloud, it allows us, in our entire company, by the way, in our entire company, all the employees we have in our company will be able to connect using a VPN into our private cloud, just like that, because we have configured OpenVPN and installing it right here. We are doing that in this description, and that is lines number 22 initializes a container, and then lines number 26 generates OpenVPN server configuration, and then you can create certificates for each individual employee in your company and give them VPN access to the cloud if you like. And we'll do that once the thing gets ready and set up. We'll be able to generate certificates and then have us install a VPN software that will connect to the cloud, and you will see all that stuff happening right away as we go along. But for right now, let us make sure that we are able to run this natserver.tf correctly. So I am going to ask Terraform, what is your plan? So please, Terraform, tell me what your plan is. So it says, okay, let me go and examine. It goes and checks the cloud, comes back and tells me that you need to add one instance. You need to do this one thing. And that one thing is what I need to do is to be able to create a machine ID. This ID number matches our variable definition in this location. This ID number, AMI ID, was picked up from the variables. That was US West 1 AMI ID. And then everything else is computed, except that it is going to be a T2 micro. It belongs to the automated VPC key name. So this key name will be injected. This public key will be injected in there. In the authorized keys file, you will have two security groups mapped to this device. And this device will belong to the security group mentioned here as well as here. One of them is the one of them is the NAT security group. The other one is the default security group. That's what we have chosen. Source destination check is going to be false. Subnet ID that we are going to select for this is the public subnet. The tag will be NAT, and VPC security group ID will be computed as a consequence of the run. So when we run this, you will see that the execution takes care of not only creating a new machine instance, but also disable source destination check, makes it false. That's what it says here, makes it false. And then establishes a connection using this username and this private key, and it remotely executes to make that device into a NAT box. That's line number 19. Installs Docker on that box. That's line number 21. Creates preparation for OpenVPN to be loaded. That's line 22. And 23 will actually run a OpenVPN container. And line 26 will generate configuration required for us to manage a VPN server in our VPC, in our cloud. So that as a consequence, we should be able to generate our own certificates for each individual employee in the company and allowing them to connect to the cloud without having to worry about that jump box or all those complexity that we have. So this further simplifies a whole lot. If you have a large number of employees in your company, all want to connect to the cloud, you could do that this way. This is the recommended approach to establish a VPN connection between your company and your cloud. So that's what we will do. We will Terraform apply, and this will remotely provision a machine. You will convert that into a NAT device, install Docker, install OpenVPN, and prepare it for us for our use. So we'll say, Terraform, please go and do it. So Terraform does it for us, and we'll say apply. So it does its thing. You will see it happening right now. You will see that it can go to create a new machine right now in the Amazon cloud. So we'll go and see the Amazon cloud, what's going on there. You will see that a new machine image and a new machine instance is still creating. 10 seconds elapsed. And then it is going to connect to that remote connection via SSH. It is waiting for it to get ready. The machine gets ready. And then it is going to do exactly what you ask it to do, which is defined in the NAT server definition. So it is going to do these things like sudo t and IP tables and Docker and everything. It's going to happen right now as you see it. In the meanwhile, let us go to the Amazon cloud and figure out what's going on there. So we'll see Amazon cloud, where are you? And here is our Amazon cloud, where you see that in the EC2 dashboard, we have one running instance, and that running instance is T2 micro, and it is running, and it belongs to the automated VPC default security group. It also belongs to the NAT security group, and you can view the corrective rules around it. The rules are allow 22 inbound from outside the internet, allow 1194 UDP from anywhere on the internet, and that's because of the NAT security group. Then we have any-to-any communication, provided it is all happening inside the security group, and that is the default behavior of the default automated VPC security group. Those two security groups have been applied. You will also see that the source destination check is disabled. Source destination check is false, and as a consequence of this machine getting ready, it is using Ubuntu AMI image, which means our username is Ubuntu. So you see that remote execution is happening right now. It is pulling Docker containers and will run Docker with OpenVPN container, and it finished. It tells us that apply complete, one resource is added, and the state of that infrastructure has been captured in the Terraform TF state file. And so we have successfully created a NAT device. Let us see if we can connect to the NAT device manually. And so we should, since it already did, by the way, there is no need to, but you could. You could get this IP address, not this, the public IP address, which is this one, and then connect to the NAT device just like that. You should be able to just do that SSH Ubuntu at IP address, and it should let you in. And we just got in. So we are there. Now let us see whether that file that I was talking about, this NAT server thing, this file, what does it contain? Let us go read that file. So I'm going to copy it and see what that file contains. You will see that it contains the number 1. This number 1 is an indicator of the fact that you are going to allow forwarding. IP forwarding is allowed. And this line, IP tables -t NAT -a post routing -j masquerade basically says that you pretend to be the box that the other box want you to. So this pretension game, or the idea of pretend, has been defined in this short video. You should remember to see that. Let me remind you where this pretension masquerading is defined. In a very short minute-long video, I'm describing what masquerading really means. And so you should watch that video if you haven't watched it. It's literally 1 minute long, 1 minute 12 second long. It describes what masquerading is if you don't know what it is. So that's what you should read on that link. I should paste a link for you if you haven't seen masquerading video. By the way, you should have. I'm not saying you haven't, but here is the link for masquerading if you don't know or understand what it means. And with that, we should continue forward. So that device that we have is called NAT. It is running. It is behaving like NAT for us, as we can see. It is acting like our NAT box. You will also notice a couple of other interesting things. For example, Docker will show you that, we need to run Docker in super user mode. So sudo su, and then say Docker should show you that it is running a busybox image that has exited. which is what we ran, and it exited because we created a place for our data container. This OpenVPN data container needs to run with this name, OpenVPN data, and that run successfully finished. So you saw that it has this OpenVPN data container using BusyBox image that it ran. And that's what you see in this listing. OpenVPN data is a place using the BusyBox image that is ready for us to use as a place to store our credentials for OpenVPN. We'll make use of that. You will also see that Docker images have been downloaded. It contains the OpenVPN image, and we are going to use that image right now in an example we will run subsequently. So right now I'm going to come out of this particular machine and back in our local workstation. We will proceed with the next step. The next step would be, now that we have a NAT device already in place, we should be able to construct our private subnet, because this private subnet has a dependency on having NAT available so that the route table routing can happen through the NAT device and then go out to the internet. And that dependency we had, which has been satisfied, so we should be able to now create a private subnet. And we should be able to move this file from here to the outside for Terraform to consume. We are still hiding these two files right now. We will keep them hidden and focus on the private subnet. This private subnet expects that you have a NAT device, which we do. And so we'll call it and we'll make use of it. And it says here that it depends on AWS instance NAT. It expects you to have a NAT device, which we now have. So it will make use of it. It will use the private subnet. Sorry, it will create the private subnet and use that VPC that we have specified, use the CIDR block that we have specified in our variable reference, use this availability zone 1A. It will associate a public IP. So say we say no to it. We don't want a public IP in the private subnet. So map public IP on launch. We'll say no, don't do that. It depends on a NAT instance. So we have a dependency called out. This subnet will be called the private subnet. So we have it clear that way. We're also going to create a route table for the private subnet. And so that route table that we have is going to use a route anywhere on the internet and allow that routing to happen through the instance that we have defined, the NAT instance. And that is the NAT instance ID that we are calling out here. And we are going to say that allow traffic to the internet as long as it goes through the NAT instance. And that is this private subnet. We are then going to make an association between this private subnet and the private route table and the NAT. Say that again. We are going to make an association between the route table and the private subnet. That association is defined here. Resource, AWS route table association, private. This association is going to happen between this subnet ID and this route table ID. Those two are going to associate with each other. That association you will see happening when we run Terraform apply. So we'll first begin with asking Terraform, hey, what is your plan? So Terraform will go and look and tell us that, you know what, you seem to not have a private subnet and a private route table and an association. And so I need to create one. And by the way, the security groups you have, it forces creation of another one. So it forces new resource. So there are these new resources we need to expand. And I'll tell you what it means. It basically means that the instance ID that you have created, that you had to begin with, will have to be regenerated. So it has to destroy the NAT and create a new NAT, because you need to make sure that it includes the existence of this private route table. You have to have the private route table allow traffic. So you're basically forcing destruction of the old NAT, creating a new NAT. And you are going to do that because of the fact that you're now expanding creation of a new route. And so in effect, what you will see is there is a minus and a plus. This minus and a plus indicates that you have an NAT device, but I cannot make use of it. So I need to recreate that resource because that resource is stale. That doesn't take into account the fact that we have a new established private route and a private route table. And so those things need to be included in your security groups. And since you have these new items getting created, it is basically forcing you to generate a new security group resource, which in turn forcing you to destroy the minus sign and create the plus sign for a NAT instance. Essentially, what you will see is the NAT instance you currently have will be destructed, and a new one exactly the same way computed with injection of new ideas, which are a new route table for private and a new subnet private and an association which contains the new the association contains an association between the route table and the subnet. Those two association needs to happen. The route table or route has to allow a traffic to anywhere on the internet using the new instance ID that we are going to generate. And that new instance ID will be created. So you will have one plus sign, another plus sign, another plus sign, 3 plus. And a fourth one is a plus minus that indicates that this NAT instance will be destructed and a new one will be created. So there are 4 things to add and 1 to destroy. So that's what you will see Terraform do when you run Terraform apply. You will see that the first thing it does is destroys the NAT device and then creates 4 things. You can see that happening right here. This device will be gone momentarily as soon as you refresh. And it is shutting down right now. And then it will create a new instance NAT. In the meanwhile, you will also see that in the VPC section, there is a private subnet constructed in your VPC for the automated VPC. In the subnet, you should see, is it there yet? Not yet, still destroying. So, so when the destruction finishes, you see a new private subnet created and a new routing table created, and all that will happen when this happens, and it should happen in 2 minutes roughly. And you will have a connection attempt to this new IP address, and that connection attempt will inject itself by the way, first thing, it will make it a NAT by changing that masquerading route to allow IP forwarding. It will also inject Docker and run OpenVPN in a container and then come back saying, yeah, we did it. And then it will go and create those private subnet, private route table, and make an association between the two. You will see that happening in Terraform and also in this location right here. As soon as you see this EC2 action finish, which is a create action. This machine create action is happened. The old one was terminated. The new one is running, is initializing, and that's the new IP address for the NAT device. And that's what you're looking at. And there is a question. The question is, it looks like the public IP is reused on the NAT machine. It may or may not have. I don't know, but I can find out if it did. It typically does or does not, depending on the cloud provider. Some clouds will give you the same IP address, others don't. It doesn't bother us because we don't care about the actual IP address, because we can use in production, we can use elastic IP address. So we can just get static IP assigned to us and just reuse that one. And static IPs are a little bit of cost. So it's probably something like $5 a month. I don't know what the pricing may be, but the static IP, they're called elastic IP. In Amazon, elastic IP pricing will be something like a $5 roughly. Where is the pricing? Understanding. Okay, come on, give me the pricing of elastic IP address. Yeah, you find out the price. I'm not worried about pricing. It's not expensive though, not super expensive. And back here, this thing finished creating 4 resources, 1 destroyed. So now the question was it the same IP address or not? We can find that out by doing history search. So historically, we have done an SSH attempt. So you see that the SSH was 212.228. That was the old IP address. Currently, the new IP address is different. So it's a different IP address, 54, 183, 184, 124. So it's a different IP address. We should be able to connect to that machine. And there we go. So we got connected and all that good stuff. So this is a new box, new NAT box. ifconfig shows you that it is on the 10.128.0, meaning the public subnet. You see that public here. It should be 1 here. It will be 1 if it is private. That's how we have defined our CIDR blocks, CIDR. This will be 1 for private and 0 for public in our definition. It also has Docker subnet and a local loopback address. And that's that machine will come out of it. And we will notice that the private subnet has been constructed by going to this location and examining the VPC. For automated VPC, you will see that it has a subnet called public and private. The private subnet is now available and ready. We'll also see that there is a route table called the private and public. They're not labeled properly, so we can label them manually. You will see that this is the public route table. And it has the gateway connection as a route direct to the internet through the gateway already. It has an association with the public subnet. Nice. Now this other one is the private route table. And here we see that the association is with the private subnet, this one. And the route to the internet is going through the ENI number, which matches this I dash number. And if you look at the 01150F, this happens to be the instance ID for the NAT device that we have created through Terraform. So if you go and match this 01150F in Amazon EC2 and look at the device, look at the running device, it will match it. This one, 01150F, that's the same instance ID which is running, and it is this public IP, this private IP, and the source destination check false, and it is our Ubuntu machine with automated VPC default security group and NAT security group. And the rules look like 1194 for VPN connection, 22 for SSH connection, and all communications as long as they are inside that security group is allowed. From outside, you can either connect through VPN or SSH, those 2 connections. And that's the NAT device. It maps to your route table for private route. It shows you that the route to the internet is, if you delete that and remove it completely and then add another route and say, I want to go to the route to the internet, you could choose the gateway, but you don't want to. You want to use the NAT as a route, and that you can save. And when you save, you get this way of connecting to the world outside using the NAT device that you have here. And that was, by the way, configured automatically for us because we wanted it like that. We said that please do it that way. We said in our private subnet to have the instance ID for the NAT instance to allow us to connect to anywhere on the internet. And that's the routing table for our private subnet. And then we have an association between the route table and the subnet ID. And that's what got created in the private subnet. We still have a couple of items in the hold area. One of them is this app server. And this basically creates 2 additional boxes in our private subnet. So I'm going to remove some of these guys right now and say, you know what, you go away, and some more. Yeah, oops, I deleted the important one. Let me delete one at a time. Yeah, so we want to have these 2 boxes and would like to have these boxes run as our app servers, which is going to run Nginx as the application, a simple application. And we would like to have 2 boxes created like this picture shows and put them in the private subnet. So I would like to have app server 0, app server 1, 2 of them created in the private subnet, and they go through the NAT device, which is this device here. It also happens to be our open VPN. There is a route table for public, there is a route table for private. This route table says you go like this and then go out. Whereas this says you go directly through a gateway. So there is a gateway IGW already given to us by Amazon. And if you are on the public machine, if you're a public subnet machine, you go like this out. And that's the scenario that we have in mind. So we want to build that. And what we are doing is focusing right now on these 2 boxes, the app 0, app 1. And so we will create them. We will basically go back here, look at what our desire is, and pull that desire out into the Terraform folder. And now we have our desire expressed in this location. In that location, we are defining a couple of things. One of them is to define a new resource called instance with the label app. And there are 2 of them. Count is 2. And you're using the AMI ID provided to us. The type is T2 micro. Subnet ID is the private subnet. Security groups are the default security group. That's what I would like to have. And then key name is the key pair that we have chosen. The source destination check is false. This is wrong. This should be true. We should not even have this line. This is bad code. So this line should go away. It's not needed. It doesn't hurt, but in technicality, it is wrong. So I just found a bug. It will still work all just fine, but technically, you do not need to disable source destination checks for application servers. This disable line is unnecessary. So that's a bug. It's a bad code. I'm going to mark it so and delete that line. For right now, I will change it manually here. I will make a note and update the Git repository to reflect that fact. But this piece of code was bad. I have fixed it. I'm going to save it. That source destination check should be true. You would like to have source destination check happen. It's a good feature in Amazon that many other clouds do not have. And that feature, you need to keep it true. Don't need to disable it. You disable it only when you want to create a NAT device. And these devices are not NAT. They are app servers. So they need to remain true. Even if you did false, it is going to work just fine, but it is technicality. And that is what was bad. And I have fixed it. And I will update the code also. So you will not run into that problem. But I'm just pointing it out that that was a bad code. It doesn't hurt though, but still bad. Having said, let's go ahead. With that understood, user data is an element of code that I want to run in the application servers. In those boxes, I will like to run this file. And that file is defined in this folder. And that file does a simple thing, installs Docker, and then runs an Nginx container. 2 things, simple things. One line installs Docker, and other line installs, runs a container with Nginx mapped to port number 80. That's what you're looking at. Port number 80 on the box outside, container inside, mapping. And that's what this file will do, which will insert that piece of code, this code, in the boxes and make them Docker containers, run Nginx as an application in those two instances. We will assign a tag, automated app 0, automated app 1, automatically increment the index count because the number is 2. So it'll automatically label them appropriately. And then the next resource is to create a load balancer. Load balancer is going to be created in your public subnet. It will have a name like this. It will have a security group associating itself with the default security group, which allows it to get access to these boxes. You want the load balancer to connect to these application instances just fine. And that will happen if you put the load balancer in the default security group, which allows any-to-any connection as long as you are in the family. So that's why this load balancer can actually make a connection with these boxes, 2 of them, because you put them in the family. And this security group allows your customers from outside to connect to the load balancer in your VPC. And that's the web security group, which allows people from outside to connect to the load balancer. That security group definition we have defined already. And then we are defining a listener. This listener will listen at port number 80 and will map it to port number 80 on the load balancer. So basically, port number 80 at the load balancer level. Let me go there. Let me go there here. So port 80 here will connect to the port number 80 here on the box, on this box, and check for health. You listen, are these boxes responding to you on port 80 or not? And that is what that listener is being set as. So the listener you're setting, if you look at port 80, listen for HTTP traffic on the instance side, and the same thing on the load balancer side. That's how you listen for traffic. And then you also check health. In the health check, you want to check on the same port 80 and look for a timeout of 5 value, interval of 15. So every 15 seconds, you check for health and you time out in 5 seconds. Healthy threshold is you have to at least have two attempts of successful consecutive, yes, I'm working, I'm alive, I'm well, or no, I'm not working, I'm dead kind of signals. Unhealthy signals, healthy threshold, unhealthy threshold. How many times of health check failures will you notice before you mark a particular device as dead is what this unhealthy threshold says. And then you define an interval for check, and you define a method of checking the health, and it has to respond on port number 80. And that's how you define this health check. And then you associate all the instances that you have created, all the instances that you created here, 2 of them, both of them, you assign as instances that this particular load balancer will need to go interact with. And that is the definition of this load balancer. And you will have 2 new automated AWS application servers created, and they will participate in a load balancer scenario, which is what we are going to run pretty much like this. So you'll have this created and these 2 boxes created. These 2 boxes will run Docker. And inside the Docker container, you will have an Nginx application running. And so the scenario would be from your load balancer will talk to 80 port to the machines inside. The machines will be called app 0 or app 1, like that. And then inside those machines, you will have Docker, which will, let me draw this picture more clearly. I think that's worth doing. So I'm erasing this. A little bit more clarity in what this container business is, which can throw people off. So what I'm going to do is make these machines a little bit away from each other. and a little bit bigger. And then draw. So here you have a Docker container running. That runs your Nginx application. And that is exposing port number 80 to the machine. And so this machine has a port number 80. This machine is called app1. This machine is the load balancer. It has a port number 80 that is going to listen for at this box level. And that port on the box level is mapped to this port at the container level. And that is how this load balancer will listen at the box level, which in turn gets translated to the container level running this application, Nginx application. So this user, when they hit the port number 80 outside, the port 80 internally to the load balancer will listen for port 80 traffic on the machine here, which in turn will listen for port 80 traffic inside the Docker container. This is just an example of something running Nginx container in Docker in this machine. That's what you will see in more clarity if you see it at a greater depth. That's the reason I would like to draw it like this, as opposed to just arbitrarily say that Docker runs magically. No, it is not. It is logic, not magic. So that's what visually you will see the same thing here. Another container mapping its port 80 to the machine port 80, which in turn talks to like that. And this machine is app 0. This was app 1. Okay, back here. So there's a question. Question is, it looks like the IP, no, we answered it. Public IP is reused. No, it's not, doesn't have to be reused. You can reuse by using Elastic IP. Back here. What we now have is a new resource file, appserver.tf. So we want to ask Terraform, hey, what's the plan? And so give me the plan and says, okay, let me go see. It goes to the cloud and compares and finds out you don't seem to have those app servers running there, so I'll create for you. And by the way, since you are creating them, I will have to destroy your NAT again and create one more time. So there are 4 changes to happen and 2 to change and 1 to destroy. Let's go see that, what is going on. So lots of things happening in this particular change. One of them at the very top, it says, I will need to create a load balancer. By the way, these pluses and minuses, don't let that confuse you. It does not happen like this. If you run the whole exercise in one shot, it just does the whole thing in one attempt successfully without having to destroy and create again, because we are running the exercise in a piecemeal fashion to help us understand level of step-by-step build up as we go along. That is the reason why you are looking at this scenario where a bunch of things getting destroyed and created again. It doesn't happen in real life. In real life, you don't run exercise like I am doing. I'm doing it in a very weird way, item by item, piecemeal by piecemeal, to illustrate a point by point description of how this tool runs. In real life, you don't run it like this. You just run in one shot, the whole thing gets created, and you're happy. You run it exactly like the way I ran the very first time I ran it on Saturday, which is I just said Terraform apply, it did the whole thing, and in 2 minutes we are done. But right now, we are breaking it down to understand what is going on under the hood, one step at a time. And that is why you see what you see, which is this destruction happening occasionally. And so now this is the last time you will see the destruction, because this is the last item on hold. There is only one item, which is an output, which is basically shows you the result of what got created. And that is not that complex. So it's basically an expression of a result. It doesn't create anything. So that's the last item we will do. But before that, we have this thing to understand. So let's understand what those changes are. We'll go to the top and read. The first thing, it says, I need to create a load balancer. And I said, great, do that. Next. It says, I need to create an app instance app 0. I said, great, go do that. I want to create an app AWS instance app 1. I said, go ahead, do that. It says, I will destroy your NAT and create the NAT again. And I said, why? And it tells me why. It says, you are forcing new resources because of change in your creation that you're doing. So I'm going to destroy your NAT and create it again. This will not happen if you run the whole exercise in one shot, by the way, as I said earlier. And then we have a route table private that you had to begin with. It will destroy that route table and create it again. Hold on, let's see if it's creating again or not. No, it is not a deletion. This is not a minus sign. This is not a minus sign. It is a tilde sign. So it is not destroying it. It is recreating it. It is recreation of a private route table. And this is also not a minus sign. Minus sign will look like red in color. This is cyan color according to what Terraform thinks it is. I have no idea what color it is, but it is not minus. It is not negative. This is a tilde sign. It indicates change. So change is happening on the private route table. It is basically getting recreated with a new NAT instance ID because you have a new NAT. So it forces a change on the route table, which is expected. And then this AWS route table public is also basically recreated. And those two changes are happening. You will see one destruction, which is your NAT destroying, and 4 things getting created. The 4 things are a load balancer, app 0, app 1, those 2 new instances, and a NAT getting created and a NAT getting destroyed. That's what you will see when I say Terraform apply. It will do those things for us as we discussed. And that's what you'll see happening. It will first thing first go and kill that NAT. So we will go and see what's going to happen. It is probably killing that NAT right now. And it is creating a new NAT. So it is creating 2 new servers and a NAT. And you will see the shutting down happening and 2 new creations happen. And you will also see a NAT getting created and all the things that we were specifying in our description. You will see them getting created. First thing I'm noticing right now it's doing is that it has app 0 getting created. It has destroyed the NAT. App 0 creation is happening. App 1 creation is happening. Then we will see that the route table public has been modified. We'll see that it has load balancer created complete. It is NAT still destroying. It says destruction complete. And then it is going to create a NAT again. And it is going to connect to the NAT device. It is going to make it a NAT by modifying the IP table's route for masquerading. It will also include Docker and make it a open VPN server. It will also have refresh. And you will see that 3 new machines are up and running. One of them, this one, is the NAT device that got created. And the other 2, this one and this one, are the app 0, app 1 machines. And I will have these 2 up and running, and you should be able to see that a load balancer is also in play. That load balancer is currently has 2 instances that are out of service. Those 2 instances are not responding yet. Those are the app 0 and app 1. They are out of service because the health check is failing And so the listeners are active, but listening and seeing that the health check is consistently failing. So the instances have been marked as out of service. However, we know that it is actually getting constructed. And so those two devices instances, app0 and app1, are getting built right now. And so those things will install Docker and install Nginx, and all that good stuff will happen. And when that happens, then the Nginx container will respond. As a consequence, the machine app0 will also respond. And when it does, you will see that the load balancer says that I can talk to these boxes on the backside. So it will then mark these two in service. You will see that happening as soon as those boxes come online and alive. And that will happen as soon as the activity finishes and responds. Right now, the NAT is still creating, and we will see that. Let it finish. When it does, we should have a fully functional setup. And at that consequence, what I would like to see is the same exact situation which you saw Saturday morning. So Saturday morning and 4th of March, when we ran the whole exercise in one shot, in 2 minutes, the whole thing finished. That is what the outcome I expect to see as soon as this remote execution on the NAT device finishes, which basically is installing Docker and installing OpenVPN right now. And so that is what is finishing up in a moment. And as a consequence, you will have Terraform come back and tell us that it did. And so it is finishing up that right now. And it did. So we have 4 resources added. This is the NAT device, 2 application servers, and 1 load balancer. 2 changed, meaning the thing that changed, which is the route tables, and 1 destroyed, meaning the old NAT. So now we have this Terraform shaped up, which is what that last file we added was, this idea of creating a app servers, these guys. And those are now up and running. Well, the last item we have in our hidden old folder is the outputs file. So what I'm going to do is bring that out also, bring this file out to the Terraform location and just ask Terraform, what is the plan? So Terraform, give me a plan. And it says nothing much. I'll just show you a nice output of what we have done in a summary fashion. That's what it'll do. So it'll say all the resources are exactly how you see. Oh, no, I don't want new NAT instances. Oh man, it's going to create a new NAT instance. That'll be a waste of time. So I think we are already going out of time, 7 minutes, 6 minutes into outside the boundary. So what I'll do is I'll let this exercise repeat the whole thing, and I want to actually discuss the next topic the next time, which is this VPN connectivity and so establishing corporate access to a virtual private cloud. How do we do that across the company? We'll play those scenarios, but right now I am not going to have these devices recreate. You have seen it already, enough of it. So what I'm going to do is destroy the whole plan right now, and next time when we run a session, I will run the whole exercise. It will finish in one shot, as you know already. And then we will go into the idea of a VPN connection, and that we will be using and discuss furthermore monitoring aspects, security aspects, and Docker Swarm, and the use of Kubernetes and some of the new technologies that have evolved in the last couple of months. Like, for example, this new thing called Swarm mode. We'll talk about that and do exercises in that context. So we will discuss that. If you have something that we have, I think we have how many more sessions left? So we have today is March 7th. We have 9th, and then on 11th, on Saturday morning, we finish that day. So we have basically 2 more days left. In that, the plan that I have is to discuss aspects regarding VPN, virtual private networking, establish corporate connections between point to point using OpenVPN software. We will have a discussion on monitoring a cloud. How do you monitor and how do you make use of automated methods of monitoring? and discuss Docker Swarm and Kubernetes. That's the plan. If you want us to still cover something specific that you have in mind, please bring it on. If I find that more than 2 or 3 people want to discuss the same thing, I will discuss that in a class setting. If you want that discussion to happen separately, one-on-one, I welcome that as well. With that, I will pause the recording for today and resume this same exercise with discussion focused primarily on security and virtual private networking the next time, which is March 9th at 4 o'clock Pacific time. And it also means 7 o'clock Eastern time. And that's when I will see you again, March 9th, Thursday. And with that, I will pause the recording right now.
Thank you, Nilesh.
Thank you very much.
Have a good evening.
You too.
Okay, bye-bye.
Bye.